Good morning, students. Hope you all fine. And I am your new physics teacher, and my name is Shruti. And due to this corona season, we cannot meet each other, and you should stay home and stay safe. We can meet after this all these circumstances overcome, and we will learn more about us, right? Okay, then I am dealing with your physics chapter light, reflection and refraction, right? Light, reflection and refraction. Okay, this is your chapter, first physics chapter in your science text, that is in the 10th chapter in your science text, right? The name light, reflection and refraction, right? Before directly going into that, we can discuss how we see things around us, how we can see an object. Say, how we can see an object? You can see me, right? You can see me. Here I am teaching you, right? How you can see me? If I am teaching you in a dark classroom, that means the light, there is no light. There is no light from out, sunlight, no bulb light, right? Then you can see. Can you see me? No. If the room is dark, you cannot see me, right? So, how this happens? What means? How we can see an object, or how we can see the things around us? Do you think about it? Do you ever think about it? Okay. What is the reason behind this? We can see that. On lighting up the room, we can see the things in this room, right? So, an object reflects light that falls on it. This reflected light, when come into our eyes, we can see that thing, right? Which means when sunlight falls on an object, it means when sunlight falls on this, or this bulb, this light falls on the duster, and the duster reflects this color, right? This color, and we can see that when the light come into our eyes, and some other biological things happen in our body, right? So when we can see this, means the reflected light when come into our eyes, then only we can see this duster, right? So you might have learned about the fraction light consists of, visible light consists of VIBGYO, right? It's an electromagnetic wave ranging visible region, right? You might have studied about it in our earlier classes. I think you might have studied, right? So leave it. We don't need that. So here there is so many natural phenomena associated with light, which means firefly is flying, which means the light, blinking of light, right? And there is this time we can see what? Rainbow in sky, right? It's also a natural phenomena associated with light. We now discuss through this chapter these phenomena and how does these phenomena happen, and what are the things, what else the things, how the light works, and how we can see the objects, and what are the reasons behind these natural phenomena associated with light, and some other things. The basic things we have to study, that how the reflection happens, and how the refraction happens, what are the effects of that, and some other things, right? Then we are studying about light. So how light travels? Is it needs a medium to travel? No, light can travel through vacuum, right? Light can travel through vacuum. And how it travels? Light travels in a straight line, right? Light travels in a straight line. Maybe there are some opaque objects in the way of light. Sometimes it may bend in around the small opaque objects. There is another phenomena termed as diffraction happens, right? There is no need of a deep study in refraction or diffraction. We have to study the basic things from here onwards, right? Reflection and refraction, and the diffraction and some other phenomena. The light may associate light may be of dual nature. You might have heard about it. Light have dual nature, right? One is wave nature and another one is particle nature. It's all about higher things, right? Some of the phenomena can't explain with the light wave nature. So there must be another nature, right? Some of the other phenomena can't explain with the particle nature. So that means light have dual nature. Okay, this is all about higher things you might have studied in your higher classes, right? So in this chapter we shall study the phenomena of reflection and refraction of light using the straight line propagation of light. We already said that light travels in straight line, right? So this basic concept will help us in the study of some of the optical phenomena in nature, like rainbow, formation of rainbow, and what are the other things. Yeah, we can study while doing this chapter, right? So we shall try to understand this chapter, the reflection of light by spherical mirrors and reflection of light and their application in real life situation. What do you mean by spherical mirrors? Have you familiar with spherical mirrors? You might have familiar with it. What else? What should I say? The spherical mirror. You might have seen that in deep curves in roads, right? Deep curves. There is a mirror. There should be a mirror to see the vehicles from here and from here. When there is a deep curve, there should be a chance of accidents, right? So avoiding these accidents, there should be a mirror, a concave mirror. I should say concave mirror, convex mirror, right? The mirror bulging outward, right? So we should learn that what is concave and convex, right? Before that, these are I should say these are all spherical mirrors, part of spherical mirrors, right? We have to study what are spherical mirrors, what are the peculiarities, and some other things. Before that, you may you might studied in earlier classes the laws of reflection, right? Can you remember that? What is the laws of reflection? Can you remember that? Look at here is a mirror or a reflecting surface, right? Here is the reflecting surface and an incident ray falls on this surface. That is, an incident ray falls on this surface and it reflected back, right? It reflected back. Then what is the law of reflection says? What is the law of reflection says? The angle of incidence. Here we can draw a normal to the plane of reflection, right? This is, suppose this is the normal to the plane of reflection, right? Here the law of reflection says that the angle of incidence is equal to the angle of reflection, right? Suppose it may be a 30 degree. So the reflected angle might be 30 degree, right? It should be 30 degree. So the first law of reflection says that the angle of incidence is equal to the angle of reflection, right? And the second law says that the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane, right? You can see here the incident ray and the reflected ray, and also the normal to the mirror at the site of incident, which means the point of incidence, right? The normal, the incident ray, the normal to the mirror at the incident point foci or focal, and what are the other things? And other things are basic introductions, right? What is reflection? What is the law of reflection? That all you already learned, right? So we have to learn more about spherical mirrors and the image formation and how it forms, and the focal length and sign convention, and some other things. Many things we have to study. Okay, that we all discuss in later classes. Today we are winding up, and you should read your textbooks. All the definitions are given to you in your textbooks, and you should read thoroughly your textbooks more than 2-3 times, right? And there are some activities given to you. You just read and try to do that activities. That first activity is given to you is seeing a spoon, the image formed by the spoon in inward surface and outward surface. That are already you are familiar with that. Even though you should do that, and the observations you will have some observation, and you just tell to me, or you just share that observation with your friends and family members, or you can share with me, right? And another activity given to you, we can discuss in later classes. Okay, so till then, take care, students, and read your textbooks and do the works. Do proper study. We can meet in next video. Okay, till then, goodbye.